down the answer. So 4 factorial is that's like your work. And then you write down the answer by either multiplying 4 times 3 times 2 times 1 or typing it on your calculator. But I don't know that 4 factorial is correct. Let's take a look at it and see. Jake must choose 4 teammates with whom to shoot around. There are 10 men on the team. Are these, is that a permutation or a combination? Combination. He's just picking some people like a committee, right? I these are people I want to do stuff with. I'm not saying you're the point guard and you're the whatever center and you're the whatever. That's not how it's doing. We're just randomly picking 4 people. So that would be 10 C4.
Yeah, look, who said 4 factorial?
Okay, that is not 4 factorial.
Yeah, look, who said that?
Not really specific.
If he was picking people for specific jobs, different from each other, then it would be a P. But since this is just 4 guys all doing the same thing, it's 10 C4. Does that make sense to everyone?
Yeah.
What did you get?
210.
What? 210?
Yeah, that's
Alright.
right.
Mara is going to assign the following roles on CHS Live.
Permutation.
Anchor, sportscaster, jokester. There are 12 students eligible. What?
12P3.
12P3. Does everybody see the difference between question A and question B?
Because the order matters. You're assigning.
You're assigned a task, a specific task. So what is 12P3?
1320.
1320, same.
Good.
Kara must tell Coach White that she cannot play in 4 of the 21 games this season.
Permutation. C.
Well, it's kind of a bad question.
We don't know what.
So, if it's a situation where
Oh.
Kara's doctor has told her that she can't play, that 21 games is too many, that she can only play 17, then it would be 21C4, because Kara gets to pick the 21 game or the 4 games that she can't play. But if Kara has her calendar here and she has specific dates that she can't play in, then it would be a P. I believe when I wrote the question, I meant it to be a C, but you could make an argument both ways. It's just an unclear question. Kara's doctor has told her she can only play 17 games this season, okay? So she's gonna pick 4 of them to sit out, any 4. 21C, no, 21C4.
5985.
21C4.
Was it?
Beatrice is gonna take 2 of her 7 siblings to the movie. 7C2. Beatrice has to pick 2 of her family members to take to the movie. No specific jobs, we're just going to the movie, so 7C2. Meg is gonna give her 4 sisters her favorite math possessions, her calculator, pencil, binder, and marker.
4P4.
4P4. 4P4. She has 4 sisters. They're all getting, or she's giving away 4 things, and order matters because she's giving away different items, right? All right, evaluate 22C20 by hand. Okay, so we kind of talked about this yesterday also. 22C20 would be what? 22 factorial
22 minus 20.
over 2 factorial, 22 minus 20, and then 20 factorial. So we start with the big number on top,
Bless you.
then we subtract, and then put the smaller number down there. So it says, show all work, do it by hand. So what's 22 factorial? 20, 21, 20, 19, And this is 2 times 1 and 20, now you see what's gonna happen, guys? All that's gonna cancel, right? 2 goes into 22 11 times. So your answer is 11 times 21, which is 231s.
Yep.
All right. So calculators make it easier for me, but I don't absolutely have to have them because a bunch of stuff will always cancel out. So it's not like you have to do a ton of multiplication. All right, I have 8 flavors of cake, 10 flavors of icing. How many different graduation cakes could I make? For this problem?
8 times 10 factorial.
Yes, 8 times 10.
Oh, so it was 8.
Just 8 times 10. So I'm gonna make a cake for your graduation party, okay? You're gonna have a cake and you're gonna have icing. How many choices of cake do I have? 8. How many choices of icing do I have? 10. When you start doing 8 factorial, guys, you are taking those 8 kinds of cake and you're laying them out in a row and arranging them. Is that what's happening? No, I'm picking one. I just happen to have 8 choices. Remember the license plate problems we did?
Yeah.
This is like that. Remember the jumper sure problems we did? This is like that. I'm choosing 8 options, 10 options, 80. How many ways can I arrange the letters of the word you are my favorites? Well, what do I start with?
You count the letters.
Count them up. So first, I count them up.
17 factorial. You already had that, like, you're good though. Appreciate it.
And then there's 17. 4 pieces. So 2, how about 2 times
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Did you get 17?
Yeah.
Alright, so we start with 17 factorial. Count up the total letters. Then start checking for repeats. So what have we got?
We have 2 O's.
We have O's, we have 2 O's, we have 2 of them. We cross out the O's. Alright,
2 A's.
A.
Y-O-A-E-R.
So there's an A and an
Y-O-A-E-R are the.
E.
2 E's.
2 E's,
R.
E and E.
R.
R's.
R's, R,
And Y. M. Y.
2 Y's. Okay, so remember, we do each letter individually. So if I had 3 of something, I would have a 3 factorial down here. Is that all of them? All right, remember, these are all divisions. Please don't forget, there's no multiplication in this problem, they're all divisions. So 17. Factorial. Oh, lordy. Did you get a gigantic
Yeah.
number? 1.1115
Yeah.
times 10 to the 13th?
Yeah.
Woo!
What is?
Wait, what?
So why do you have to do
I've never done that, does it work?
It'll work.
Perfect.
Sometimes repeats can be.
I've never taken a factorial to a
Sometimes
factorial.
Oh, nice, Elijah. Yeah, you're kidding. Don't, we put 2 factorials for those because there's only 2 of each of those letters. If there was like 3, say there was 3 O's and you put 3 factorial on it, yeah, okay. Because there, I just did 17 factorial divided by 36 because 2 factorial is 2. So just 2 times 2, I just did 2, or 32 I mean. I just did 2 to the power. Yeah, that number.
That, you gotta be careful, because it works for 2, because 2 factorial is 2,
Exactly.
but nothing else is that way.
Yeah. Yeah, I only do it when the numbers are small. Like if it was 3 factorial, then it's just 6.
Find the third term of the expansion. 2x minus y to the 5th. We want the third term. okay? Now, since it's to the 5th power, I'm going to look at Pascal's triangle.
You don't understand.
And it's pretty easy to go to the 5th row.
Yeah.
We talked about this yesterday, make sure you can build it if you're gonna use it. We don't want the whole row. We only want the 3rd term. So we want 10. Next to the 10, I'm gonna put a 2x and a negative y, because those are the 2 pieces of the binomial, right? Now I have to put on my exponents. Remember how that works?
Mm-hmm.
Here, if I wrote out the entire thing, here,
All
the
fives.
power on the x would be 5. Here it's 4,
And 1.
here it's 3.
Yeah.
And if that's 3,
Two.
that's 2, because they gotta add up to 5. So how did we have a quiz tomorrow?
Wait, what?
It's your taking. So how did I get those exponents again? I remembered, and you might need to go back and review your notes. When you expand, the powers on x, start with that and go down by 1,
Yes.
all the way to the end. So here it would be 5, here it's 4, here it's 3. That's how I got the 3. Then I remembered that in the expansion, each individual term, the exponents are always gonna add up to whatever that is, in this case 5. So when I made that 3, that became a 2. Now, I simplify. Be really careful.
1, 3.
What is 2 to the 3rd?
8.
8. So
It's
10
80x
times 8
80x cubed.
times 1, so 80x cubed y squared. What happened to the negative?
Makes it positive.
It got squared out. Yep, it got squared out.
Why did we choose the 3rd?
17C.
Why do we choose 10?
So
Did you read the question?
17C.
Oh.
17.
Find the 3rd term, so I counted, 1, 2, 3.
10,
All right.
9, 8, 7.
Now, the last question, we talked about this yesterday, actually when we were doing our probabilities. I bring out 5 rows of this, I do not want to write out 17. Could I?
You could.
Sure,
But that's the same.
but it would be insane,
17C
right?
14.
So instead, I'm going to remember that the 17th row of Pascal's triangle would be 17C17.
14.
In terms of what we did yesterday, this was 17 questions, getting 17 right.
Yeah.
And then we go down to 1716, 1715, which one do I want?
14. 17.
So one more, 17C14.
Oh, that's not correct.
So what is the 4th term in the 17th row? I don't know, whatever 17C14 is.
But you never, you can't just like do, because you'll think find the 4th number, so you can do 17 plus 4.
680.
So you can
So the answer would be 680.
Yeah.
All right, so tomorrow's quiz has no probability on it.
You have to simplify.
It's just like these,
You have to
okay?
simplify that or no?
I said 680.
Oh, it's okay.
So the quiz tomorrow, you will have your calculator for. You will have to do that one problem by hand. Remember the one where we wrote out combination formula and canceled, you have to do that by hand.
22.
Showing all your work.
22.
But everything else you have calculator for, and it's just like these, I promise. It's like this. So if you want to do well, you might redo these.
And minus times.
All right, friends, that's that. Let's get our notes back out. Today, we're gonna start with some card problems. Is there anyone in here who has never played cards before? Not familiar with the deck of cards? Good. So you don't need to be a card shop or anything like that. You just need to know that there's 4 suits.
Yeah.
Diamonds, clubs, hearts, and spades. You have to have basic knowledge, okay, to do these problems. So here we go. Consider being dealt a 5-card hand from a standard deck of cards. We are in 9-3, number 2A. Yesterday, we pulled M&Ms out of the bag and found probabilities.
Yeah.
Today, we're finding probabilities with cards, and it's done a little bit differently. So here's what we do. All right, number 1, how many 5-card hands are possible? So you know this.
3, 2.
How many cards are in the deck?
52.
52. How many of them are you choosing? 5. How many 5-card hands are in the deck? A lot. 52 C5. Now, I don't want any argument about, oh, but order matters. There are probably some games where order matters, but this is how many different 52-card hands are there? 52 C5. Okay, that's a big number. Everybody find it or got it? It's a big number. Okay, now, I want to know, what is the probability of being dealt a hand with all diamonds? Probability is a fraction, and the denominator of that fraction is going to be 52C5. Why? Because that's how many total possibilities there are. So any problem where you are talking about probability for a 5-card hand, the denominator will be 52C5. If it were a 4-card hand, it would be 52C4. Got it? All right, now what's my numerator? I want all diamonds.
Yes.
Well, how many diamonds are in the deck? 13. And how many am I picking?
5.
So my numerator is 13C5. So remember, your denominator is the total. And as long as you're picking a 5-card hand, that will be the denominator. That's not gonna change. That's a 5-card hand total. Your numerator is what you're trying to get. Well, if you're trying to get all diamonds, you only have 13 to pick from. That does not reduce. Please do not try to cancel. The only way to figure that out is to type it in.
It's a weird number. Why is it a combination instead of a, if it's specific?
Wait, no, it's specific in terms of I want diamonds, but I don't care which order I get what diamonds. No, I just need to end up with 5 diamonds. Okay, now, be careful, because I have a feeling
Whoa, it's a weird number.
this is
Really
going
small.
to be a very small number.
Oh, 4.95 percent of the negative.
Yes, so very good, Sam. Do not forget, guys, that there is, when there's an E at the end of your problem, that means you've gone into scientific notation. So this is, it's fine, leave it like that, that's totally fine. But understand that's really this. That is a very small probability. Next, what is the probability of being dealt a hand with all face cards? Okay, wait, denominator is 52C5. that is always the denominator, always the denominator, if you have a 5-card hand.
Wait, is the Joker a joke face?
No. What about the standard debit card, 52 cards? So which cards have faces? Jack, Queen, King, all 4 suits, 12. So your numerator is 12 C5. Because now, instead of getting to pick from the whole deck, you can only pick from the face cards. And there's only 12 of them. That's gonna be even smaller, guys.
Yeah.
So 3.047 times 10 to the negative 4th. Do not bet your lunch money on the 20s. Very good. So Elijah is looking ahead at the next problem, and it's what's the probability of all red? Denominator's 52C5. Numerator is 26C5. Please don't try to reduce that. They'll be saying something like 1/2. Do not reduce that. Type it in. Now, it will be bigger than what we've had, for sure. Your chances of this are better. They're still not real good, though.
You just type this in.
Did you get .025?
Yeah.
So that means that you have about a 2.5% chance of being dealt an all red hand. Right?
Yeah.
That's still not too great, guys. That means if you did it 100 times, you'd have two hands, about 2 or 3 hands would be what you want.
That head will be good.
All right, try E. See if you and your teammates can use can get that set up.
It doesn't say specific suit, right? It's just
Nope.
3 jacks.
Yep, 3 jacks and 2 kings.
52,
We need E, probably.
52 C5 as well.
And then, oh wait.
There's
Denominator's gonna be 52C5, guys. That's not gonna change. 52C5 is your denominator.
8 C, it's just gonna be 8 C5. 8 C5. It's 52. No, it's 8 C5.
5 C
52.
five.
Bro, it said 50. Bro, we 52 on denominator.
This is kind of like yesterday when we had to pick a red M&M and a blue M&M. So we do them individually. So I need 3 jacks. How many jacks are in the deck? 4. And I need to pick 3 of them. Alright? This is 3 jacks. Now I also need 2 kings.
4 C2.
4 C2. Since I am picking 3 jacks and 2 kings, I will multiply those 2 numbers. Now I heard somebody say 8C5. Be careful, because if you put all your jacks and kings together and pick 5 cards, could you get 4 kings and 1 jack?
Yeah.
That's not what I want.
No.
I gotta pick 3 from the jack pile and 2 from the king pile, right? I gotta separate those piles to get exactly the number that I want. Okay, so does this make sense to everyone?
Yeah.
All right, we're gonna type it in. Calculators are magnificent things.
Another small number, very small.
Would you anticipate it would be small?
Yeah.
Ah, this one's really
Really
small.
small, 9.23.
9.234 times 10 to the
negative
negative 6.
Ooh. You want us to round it
You'll round off to something, but yeah.
round it 1,000?
Is the next one 40
I
40?
haven't got the next one yet.
40?
So everybody good with, what was that? E? Everybody good with E? Okay, just look it up, take a second, give a strategy, then we'll go one.
Subtract
40,
52.
yeah,
from
40 C.
however many faces.
40 C5.
Yeah.
I'm hearing, well, 52C5 is the denominator, and then I'm hearing 40C5 for the numerator. Why 40?
Because.
Because-
52 minus 12 is 40.
Exactly, Lopez.
Yeah.
So there are 52 cards in the deck. We don't want any face cards, so we'll pull those out. This one.
It's a joke.
This one is actually going to be probably the highest one so far.
25%. That's not that bad.
0.253. So you have about a 25% chance that if I were to hand out 5 cards, none of them would be. Okay. All right, one. That's the side. Equal seats, ready to learn.